So we were working on our new shortcuts for derivatives. We know how to do the derivative of a constant and if it's x to a power. If I want to know all the points where the tangent line is horizontal, if the tangent line is horizontal, what does that mean?
So there's a zero derivative.
Okay. This horizontal line has a slope of 0, so I'm looking for when the derivative is 0. So first I need to find the derivative. Make sure you are getting in the habit of labeling, like this is my original when I do my derivative, f prime or y prime, because later on we will be answering questions where sometimes we have to look back at the original equation, sometimes we need the first derivative, sometimes we need the second derivative. And if you don't label which is which, you're going to be very confused when it comes to that point. So start good habits now. What would be the derivative of this? And the derivative of 4 is 0. So I don't need that. And I just need to know when this is equal to 0. So what would we do?
So y equals 0.
Yep. So how would I solve when that's 0? What would we have to do? Four x cubed minus 12x. I don't want when x is 0. I want when the whole thing is equal to 0.
Oh, would you factor?
Yeah. Take out a 4x. If you set those equal to 0, you get x to be 0. Over here, add your 3 in square root, so plus and minus the square root of 3. I didn't really specify here if I just wanted the x values or the ordered pairs. If I did want ordered pairs, we have 3 different x's. How would I get the y values for the ordered pairs?
Just plug that back in.
You put a 0 in, you get 0 minus 0 plus 4, so 0, 4. If I put in radical 3, so radical 3 squared is 3, so to the 4th would be 9, minus 6 times 3 plus 4, so we get negative 5. If I put in negative radical 3 to the 4th, that's still 9, squared is still 3, so we also get negative 5. So those are the 3 times on the original graph, the exact order pairs when the derivative would be 0. Is that okay? Now this one, the equation of motion of a particle is 2t to the third minus 5t squared plus 3t plus 4. S is in centimeters, t is in seconds. Find the acceleration as a function of time. This is position. How do we get acceleration? Second derivative. The first derivative is velocity. So if I do this derivative, the 3 comes down, multiplies with the 2, so we get 6t squared, minus 2 times 5 would be 10t, plus, what's the derivative of 3t? 3, and the derivative of 4 is 0. Are you guys okay with how I got that derivative? I need acceleration. So we need the second derivative. So I do the derivative of my answer. So that would be
12t minus 2.
okay. And then I want the acceleration after 2 seconds. So what do we do?
Plug it in.
So 24 minus 10 is 14. Units in centimeters per second squared. Velocity would be centimeters per second. Acceleration, that second derivative makes it squared. Is that okay? All right, I want to talk about one other function today, and that is the exponential function. E, we've always just said it's kind of like pi. It has a set value. It actually comes from limits, what that value is defined as. so that this definition of a limit is equal to 1. But for our purposes, remember an exponential function, this is just a few of them, like 3 to the x, e to the x, 2 to the x. They all go through the point 0, 1. They're increasing functions if your base is greater than 1. The nice thing about this, e, because it is chosen, the value of e is so that this limit is equal to 1, it works out that the derivative of e to the x is still e to the x. Okay, so this is a very important result. This is why in calculus, anytime we're dealing with logs, we typically do natural logs because the derivative of e is nice. Same thing with exponentials, we typically always deal with the base of e when we can. So if I asked you to find this derivative, what's the derivative of e to the x?
X times E.
It has a different rule because it's not x to the power. Derivative of e to the x is still e to the x. Nothing changes. So derivative of e to the x is e to the x. Minus, what's the derivative of 1, or of x, excuse me. All right. Second derivative, what's the derivative of e to the x? What's the derivative of 1? Nothing. So that's all. I'm not going to compare the graphs since we don't use graphing calculators in here anymore. That's really not helpful in this. Do you guys want an explanation for why the derivative is e to the x? It's because of this expression, because e is the base that's required for this to equal 1. So if you think about your definition of derivative, limit as h approaches 0. If my function were e to the x, so that would be e to the x plus h, because remember f of x plus h minus f of x all over h. E to the x plus h, properties of exponentials. When you add the exponents, that means the originals were multiplied. What could you do on the top now? We could factor it out. And that would leave us with e to the h minus 1 over h. Right? As h approaches 0, e to the x, it doesn't have an h in it, so it's still e to the x. But as h approaches 0, e to the h minus 1 over h, by definition, because of the value of e, that is equal to 1. So that's e to the x times 1. So that's why the derivative of e to the x is still e to the x. In case you were curious, I could just see you guys really wanting an explanation for why that is what it is.
Pretty blatant.
Yeah, you didn't really just want to believe me on that one. You needed proof. I could tell.
We've been proven.
Okay, let's look at this one. At what point on the curve, y equals e to the t, is the tangent line parallel to the line y equals 2x? What does parallel mean? Doesn't touch. So in terms of slopes, they have to have the same slope. What is the slope of this line? 2. So if the tangent line will be parallel, the tangent line has to have a slope of 2. Slope of the tangent line is our derivative. So we have to do the derivative. What's the derivative of e to the t power? So I need to know when that is equal to 2. All right, this is really testing your algebra. Do you remember what I can add here that would cancel out?
Yes.
had a natural log on each side. The natural log and e cancel, so t is the natural log of 2. If you wanted an ordered pair, you could plug it into the original. If I said e to the natural log of 2 power, and e and a natural log always cancel each other, so you just get 2. Any questions on that one? Let's try this. If I want to find this derivative, first, I need to rewrite it so it's x to a power. 1 over the cube root of x. I would write that as x to what power? So my derivative. What's the derivative of x to the negative 1/3?
-1/3 x.
So do it for the exponent, negative 1/3 minus 1, so negative 4/3. Plus, what is the derivative of e to the x? Plus, all right, now we have to think a little. The derivative of x to the e. What do you think that would be?
It wouldn't be x to the e, would it?
It would not.
Be too nice.
Any other guesses?
X to the e minus 1.
Yes. It's x to a power. Just like we did over here, the power comes down. X, you subtract 1 from the exponent. So the e comes down, x to the e minus 1 power. Plus, what's the derivative of e to the 3rd?
E to the 3rd.
Mm-mm.
No.
It's 3e to the 2nd.
Other guesses? Somebody else has to guess.
E to 4.
No,
E to the 2nd.
no.
E.
Oh, it'll be 0.
Yes, it would. Why is it 0?
Constant, so.
It's a constant. There's no x in this expression. E is a number. It's not really a variable. It's a number. 2.78, blah, 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 blah. So this is just a number. There's no variable, so its derivative is just 0. So we just get negative 1/3 x negative 4/3 plus e to the x plus e to x to the e minus 1. That one's hard because you see e's and it's a letter, so we want to think of it as a variable. But remember, it is a set value. All right. Let's try another challenging one.
Interesting.
Interesting. Yes.
Love.
Thoughts? What could we do here?
Distribute that squared.
Okay. We've got to clean this up a lot, don't we? We can only do the derivative if it's e to the x or x to a power. So I'm going to clean this up a lot. When I have x squared times the cube root of x, the cube root is what power?
So,
What is it?
If those are multiplied, what do you do with their exponents?
Add.
Add them. So 2 would be like 6 over 3 plus 1 over 3. So that's x to the 7/3. Here we have x times the square root of x cubed. That would be x to the 3/2. So 1 plus 3/2. So 2 over 2 plus 3 over 2. 5 over minus, over here when I square, the square root of 2 squared is 2, x to the second. On the bottom, what do you do with a power to a power? Multiply, so x to the 4 thirds. All right, now I'm still simplifying this because my derivative, I can't do it if things are being multiplied or divided. We'll learn how in the next section, so next week. But right now, we have to clean this up first. If these are being divided, what can you do with their exponents? So 7 thirds minus 4 thirds? 1. Okay, 5 halves minus 4 thirds. So
3, that's what you do.
6 minus 8 over 6.
7, 6.
Minus 2. Okay, you have 2 minus 4 thirds. So 2 is like 6 over 3 minus 4 over 3. 2 over 3. Possible to get a negative exponent when you're doing this if you have more x's on the bottom. But now we've took this very nasty expression and simplified it, so it's just x to power. So now we can do our derivative. What's the derivative of x?
1.
Plus, what's the derivative of x to the 7 6?
7, 6, x to the 1, 6.
Minus derivative of 2x to the 3 halves power. So the exponent comes down, 2 times 2 thirds,
4 thirds. And
2 thirds minus 1.
that is x to the 1, negative 1.
Questions on that? Tomorrow, we are going to take a quiz before our extended weekend. I figured you'd rather do that before than after. Seems like a better plan.
Likely.
Likely. So what I'm going to do, I'm going to give you guys a little bit of time to work on the homework, and then towards the end of class, I'll review for the quiz. Okay, we have a lot of time. So this is what you did yesterday. I'm adding a whole 7 problems for today. I know, it's just unrealistic. It's going to be 8 questions, and it covers 3 things. The definition of a derivative, drawing the derivative, and using these rules that we just learned. The definition, anytime I say to use the definition, what is that?
Is that your difference equation?
So the limit as h approaches 0. We had 2 different versions, but the easiest one is f of x plus h minus f of x all over h. At the very beginning, we learned it in terms of a's because they were giving us numbers plug in. On the quiz, I'm just going to ask you to keep it in terms of x. That'll be easiest, and that'll be the notation we use moving forward. So there'll probably be like 3 questions where I ask you to use this definition. There'll be probably 1 question where I ask you to look at my graph and draw the derivative based on that. And then the rest of them would be using these shortcut rules that we've learned. So let's try a couple and just make sure we refresh. I am not giving you this definition tomorrow. It'll just say in question, use the definition of derivative, so make sure you know that. Otherwise, you're going to be in trouble. So if I gave you something like this, I want the equation of the tangent line to the graph y equals the square root of x minus 1 at the point 5, 2. Can we even use our shortcut rules for this? No. So we have to do the limit as h approaches 0. F of x plus h says you go to this function, you replace x with x plus h minus f of x all over h. Is everybody with me there? What did we do anytime we had radicals? would do that. And H approaches 0. When I multiply those two, the radicals cancel. Because they're conjugates, outside and inside cancel. Minus my x minus 1 over h times this whole thing. Now what?
Your x is in minus
We distribute that negative. Then the x's cancel, the 1's cancel. So we have, sorry ladies, good. H over h times all of that. And that's good news because what happens then?
h is canceled.
H is canceled. Now I can plug in my 0. So I get 1 over 2 radical x minus 1. Now, that's my derivative. And if that's all I asked for, I'd be done. But I asked for the equation of the tangent line. We need a point and we need a slope. How do I get my slope?
Plug in your x to your derivative.
So that's square root of 4, which is 2. So my slope is 1/4. And then we can plug into y equals mx plus b. So the tangent line is y equals 1/4 x plus 3. So are we okay with a problem like that? I think I have time to do one more. If I ask you to use the definition to find this derivative. So limit as h approaches 0, f of x plus h minus f of x all over h. What did we do? So I multiply this one by x plus 1 on top and bottom. And this one by x plus h. So then we have minus h approaches 0, 2x plus 2. If I distribute a negative 2 through this one, minus 2x, minus 2h, minus 2. Did you ladies do okay? It's all divided by h, or h over 1, so if I both them multiply, that would be 1 over h. Now what?
2x's and your 2's cancel.
So my h is dropped. Now I can plug in my 0, so I get negative 2 over x plus 1 times x plus 1, or negative 2 times x plus 1 squared. Is that one okay? A graphing one. So if I just give you a picture of a graph and ask you to graph its derivative, and it would be like this, just a sketching, nothing too precise. What am I looking for? Okay, we need to find our x-intercept. So I'm looking for where we have a horizontal tangent line. So that's here, here, and here. And we know anywhere we have a horizontal tangent line, the derivative is 0. Okay, before this point, the function was decreasing, so my derivative would be negative. Okay, then it's increasing, so my derivative is positive. Decreasing, so my derivative is, and increasing, so my derivative is positive. So, nothing real precise, but finding the correct points where it's 0, and then correctly graphing if it's positive or negative, based off the increasing, decreasing. Is that okay? And then one problem, if I ask you to use the differentiation rules, that means not the whole definition, the shortcut rules, to find this derivative. If I want to use my shortcut rules, this has to be written as just x to a power. So what would we have to do first? FOIL. This means x plus 3 times x plus 3. So anytime you have things multiplied, you have to go ahead and multiply them out. Then what would you do? Subtract our x. So we get x to the negative 3 plus 6x to the negative 4 plus 9x to the negative 5. And so now we can do our derivative. Exponent comes down, subtract 1 from the power, so negative 3 minus 1. Okay, this one, the negative 4 comes down, so negative 24. X to the, okay, here the negative 5 comes down, so minus 45. X to the negative 6. So just make sure, if I'm asking you to use the shortcut, simplify first. Multiply or divide, whatever you need to do, so it's just x to a power, and then work from there. Any questions about what will be on this quiz? So at the beginning of class tomorrow, we'll grade homework, answer questions. If there's anything you need me to review, I will.